So we looked at it using long division. We looked at it using the area model. Let's look at the same problem looking at it using synthetic division. So we divided by x minus 4. Remember, the number that gets subtracted goes there alone. Here's what we're dividing into. Just write the coefficients. Then we bring down, multiply, add, multiply, add, multiply, add. And voila, that position here is also the remainder. Remember in grammar school, R75. So as we said earlier, sure enough, the plug-in number is the remainder. Well, if the remainder is 0, it goes in evenly, so it's a factor. All those words mean something. Goes in evenly, it's a factor, remainder 0. All those ideas go together. So, if I'm going to write this out, well, here's my divisor, here's my quotient, and it won't go in evenly, so here's my remainder. As a quick example, remember, back in the day, if we had 13 divided by 4 is 3, remainder 1, which meant that 13 is 4 times 3 plus 1. 13 is what's being divided. 4 is the divisor. And 3 is the quotient. And 1 is the remainder. Okay? Now some of you were taught that the remainder is 1 over 4. But do you see that 4 times 3 plus 1/4 is not going to give us 13? So in this case, we use the whole number remainder, the R number, not the fraction. Not the fraction. But if I write the question like this, that's like writing this question as 13 divided by 4. Okay? So here is the idea of 13 divided by 4. Well, we get the quotient, and so dividing here, the quotient is 3 plus, now, if I write the remainder of 1 is 3 plus 1, this fraction. No, it is not. But if you think about it, that's where the fraction remainder comes in. This fraction is 3 plus 1/4. Isn't it? It's 3 and 1/4. And that's the same thing we're doing here. We're adding the remainder as a fraction. Because, watch, if I go over here, is 13 the same thing as 4 times 3 plus 1/4? Well, there's 12, and look, there's one more, which is 13. And if you look at this one more time, 3 times 4, well, isn't that what this is? And then plus 1, isn't that what this is? So they're really the same thing, one from the other. So the remainder theorem. we just saw a moment ago, if I plug in a into the polynomial, the plug-in answer is the remainder. When I take the polynomial and divide it by x minus a. We saw earlier that if that remainder is 0, then this thing that we're factoring or dividing by is a factor. That's only if it's 0, so that would be the factor theorem. Here, if the remainder isn't 0, we can still talk about the remainder theorem. So here we go. Remember? Here's our division algorithm, which we talked about a moment ago. It's like 13 is equal to 4 times 3 plus 1, where 4 was the divisor, 3 was the quotient, 1 was remainder. Or over here, if I have 13 divided by 4, it's 3 plus the remainder, but this time the remainder has to be a fraction. Do you know which one to use? Here you add just the remainder, and here you add the remainder as a fraction. Do I start out with the question being a fraction? Do I start off just with a polynomial? So this time, since we're starting it out as a fraction, this is going to equal 3x squared minus 2x minus 3 plus, because my original problem was a fraction, my remainder has to be a fraction. The remainder over the divisor. And I use the area method because my divisor has a coefficient of 2. And hopefully you can go ahead and try the area model on your own to remind yourself how to do it. Here are the numbers that you use. Don't forget, this is what you'll look at with the remainder. Now be careful. When you see this notation, I'll bet you the first thing you do is, oh, I plug it in here, 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 and work it out, and you'll get a stomachache, because thinking about plugging this in here, here, and here is way no fun. But if you remember that if I plug in, I'll get the remainder, because the 7 over 2 came from this, remember? If I have 2x minus 7 and I factor out a 2, that's x minus 7 over 2. Okay? So it's like dividing by this. So I can use a 7 over 2. And since I know the remainder is 6, the plug-in answer is also 6. The plug-in answer is the remainder. Here's that k problem again. So we're going to plug in 2 because it's x minus the factor, or 2 minus 2 gives us 0. The remainder is going to be 11, so the plug-in answer is going to be 11. I plug in the 2 here and here. Don't forget order of operations, you square before you multiply. Get the k by itself, using algebra 1, and the k is 2. What is k? K is 2. That was the goal. Now, since x minus 2 is the divisor, I can use synthetic division. This is from the x minus 2. Here are the coefficients. For the moment, we have k here. So we bring down, multiply, and then add. And we know that k is 2 because we're checking this. We're checking that k is 2. So when we add, we get 6. Multiply, we get 12. Add, and sure enough, we get the remainder of 11 again. So the 2 does